Welcome to the HVAC Game School Community weekly live call on Wednesday morning, drive to work Wednesday. So we'll take a moment and talk about fall PMs because the fall is soon upon us. And actually today I'm going to my first fall PM for the year. And I guess it depends a little bit on where you're located and what kind of furnaces or electric heat, or if you're working on oil or gas. But the thing that is different on the fall PM to other PMs is that you will also engage the heating and you will test the heating to make sure that the customer is set up for the colder season. And that just requires additional steps. So I wanted to go a little bit into that and then maybe cover some kind of controllers or on refrigeration, because I've run a lot of refrigeration calls lately where coils are freezing over. So anyways, we'll just get started and then we'll see if you have questions. You can just ask me and maybe somebody else joins. We'll see. But yeah, on the fall PM, I mean, generally on the PMs, what you go through is you do a full system check. You make sure that the system is running. You're putting your temperature probes. You're making sure that you're getting your temperature split on the supply and the return ducts to ensure that it's properly cooling or properly heating. And you're checking electrical connections. You are checking. Well, if you notice, usually I try not to hook up gauges if I don't have to, because you're always accessing the refrigerant, and there's always a chance of contamination or losing refrigerant charge. So I always try to hook up my gauges only if it's necessary, if I see that something is wrong with the system, or if the customer specifically requests it. Like some customers, they specifically request pressures from the system. But you can get most of the system operation by just observing the airflow, by measuring the temperature. You're supposed to have about a 20 degrees temperature difference between the supply and the return. So if you're getting, let's say, 80 degrees on the return coming back from the building, you would be looking for around 60 degrees of supply air on the supply duct. So that's something, if you're getting less, you know that there might be a refrigerant issue, there might be a restriction, there might be something wrong with the heat removal and the condenser. And if you're getting too much, like let's say you're getting like 22, 23, 24, it might be that you just have like lack of airflow is usually what I find most common. Wow.
Uh-huh.
Wow. Somebody just cut me off.
Okay.
Wow.
Okay.
Yeah, like either your fan is not running fast enough, the belt is slipping, or your filters are clogged. It could all be leading to increased temperature difference, because the way it's designed is the evaporator coil has the right amount of refrigerant on it. Then you will pick up a certain amount of heat, which turns the liquid refrigerant into a vapor. And through that change of state, you basically get all your heat removal and your heat transfer. So if you get like too much, like if it's dropping too much, because it always has a design value, but if you're dropping too much, then you're not getting enough of the hot air passing through the evaporator coil, which then will give you a larger drop in temperature because there's less air that you're removing heat from. So that could be an issue there. But yeah, you're just going through everything. You're making sure that like you're reading your amperage on your components. You're making sure that it's per the specifications, and the specifications are usually on the data plate. Like it tells you, for example, condenser fan motor, 1.4 amps. So if you're reading 1.6 or 1.7 amps on the condenser fan motor, I would also check the capacitor, because that might be a likely cause why it's pulling too much amps. But if the capacitor is good and you're still pulling too much amps, it could be that your condenser fan motor is failing or it's going bad. Like it could be overheating or the bearings could be going bad. So it has a harder time spinning or turning, which then causes a higher amperage draw.
Okay. All right. Uh,
One second, I just need to
mhm.
see where I'm going because I'm almost here. And
Oh, wow.
yeah,
Wow.
was a very close today, very close call.
Very close call.
Yes. And so yeah, that's things you check for. And then if you have like loose electrical connections on your contactors, you see like burn spots or black wires or like things that like look like they overheated, maybe like melted plastic or things like that. Or
Uh-huh.
also if you're looking into, oh, I'm here. Interesting. I've never been in this location.
Wow.
That's so interesting. Oh.
Okay.
Yeah, and then after you look through your electrical connections, and always make sure that you're safe while doing that and you're turning power off as needed to access the equipment. Obviously, if you're checking how much amps you're drawing, you cannot turn the power off because the power needs to be on to check that. But if you are tightening electrical connections or you're replacing connectors that are burned up, then yeah, turn off the power to be safe on that. And then also inspect the contactors and make sure that they're not burnt or pitted inside because you have metal connections and they open and close. And when they open and close, they spark every time they open and close a little bit, which then wears out the contacts. So once you're going through all your electrical connections and your um, contactors and note down, it also depends on your customer. Either you note down all your deficiencies or you just replace it on the spot, depending on the contract that you have with the customer.
Mm-hmm.
But that is all things to check. And then on your fall PM, you additionally also engage the heating, which I always recommend to leave the I mean, in some units it's not possible, but if you can, leave the compartment where the heating elements are located open,
Mm-hmm.
because once you engage the heating, usually you'll have dust or dirt accumulation on the heating elements if it's electric heat. And even if it's gas, I've never worked on oil, so I can't really speak about oil. But once you have gas, you have burners, and they also tend to get dirty over the year.
Mm-hmm.
And once you first activate it, you'll get like a very bad burning smell
Mm-hmm.
that you don't necessarily want to get into the building with the customer there. So I always try to leave the panels open, maybe the panel to the fan, so it's pulling more air, so it dilutes it more, or just leave the compartment for the electric fan, the electric heat open.
Mm-hmm.
So the air just doesn't go into the building, but it just escapes outside. And then make sure that your amp draw on the heating element is correct.
Mm-hmm.
And then also what you can do on the heating elements is you can check resistance, obviously with the power off. You check resistance across the heating element, making sure that you're getting resistance.
Mm-hmm.
It really depends on the heating element, on the voltage, and how much amps it's supposed to pull, what resistance you're supposed to get. But yeah, it can be anywhere from 15 to 50 ohms. It can be higher, it can be lower, but that's what I kind of see on my commercial units.
Mm-hmm.
And also, if you're reading OL on some of the heating elements,
Mm-hmm.
that means that that your heating element is broken inside because there is no continuity. And the way electric heat works is the wire basically provides resistance to the electricity, which then heats up the wire. And
Mm-hmm.
that is literally what generates the heat. So you're pushing electricity through a wire that has resistance on it, which heats up the wire. Basically same to like a light bulb, like the original light bulbs, where
Mm-hmm.
they heat up because you have the little filament inside and you put power through it and then it heats up and it creates light, like it glows. So similar concept.
Mm-hmm.
And then on your gas, in your gas heat, what you want to do is obviously check all your components, make sure your gas valve activates, make
Mm-hmm.
sure that your control board is good, make sure that the flame sensor is registering the flame and actually keeping the unit on. And then also you have a pressure switch on there, and you want to make sure that your pressure switch opens and closes. And I would test that several times because it happens quite frequently that you test the component, but then it still fails in the heating season. And sometimes they get stuck and you can just tap on it and it like opens and closes again. But you definitely want to recommend replacement in that scenario because you don't want the heating to be out when it's most needed.
Right.
Like, yeah, last year in Texas, there's really like only 2 or 3 weeks where it's like really, really cold, and then everybody calls about heating. But I know other states are different and you have longer cold seasons. So you really want to make sure that you're taking care of the customer ahead of time. And you also let them know all the deficiencies that you find. And even if it's not failed yet as a component, but you see that something is going bad, just notate it and say, this is still working, but based on my measurements and the values that I'm supposed to be getting, it is likely to fail in the next month or 2 or 3 months, or you can't really say most of the time because sometimes it lasts for a long time. Also depends how much they use it. But just let the customer know how their equipment looks because that's what they're paying you to do on a PM is to go through and notate and let them know of anything that's about to fail or that could be failing, because that's why it's called preventative, because you're there to prevent the equipment downtime, really. So those are all things. And then obviously, I mean, on your PMs, you would replace filters and you make sure that the coils are clean. Some customers, they have coil cleaning on the fall PM, some they don't. And many customers, they just clean condenser coils. They don't clean evaporator coils. But that is also very important because it can restrict the airflow quite a bit and cause all kinds of other issues. And yeah, that's pretty much it. Make sure your gas pressure is good. Like you're supposed to have a manometer and the gas valve, you can test it with your manometer and check the pressure. Make sure the pressure is as indicated on the gas valve. So those are the things that I wanted to share.
Okay. And so, obviously, from the viewpoint of the customer, you would always recommend to get them start the heating before the heating season, because otherwise, if it doesn't work or there is dust, as you said before, they won't be able to detect it, right?
Yeah, I mean, that's what you're doing. The fall PM is you're doing the preventative maintenance in the fall season. And that's where we and our company first engage the heating to make sure that the heating is running before it really becomes an issue. Because honestly, now it's September and the next PM will be in 3 months from now if you're on a quarterly schedule. So that will be in the middle of December, which usually is already too little too late. So like you already might get some cold spells before then, especially in colder climates, more up north. In Texas, it's not as much of an issue. And where I was before in Florida, it wasn't an issue ever, really. So I even had units that didn't have heating at all. So, yeah. So, but that's why you want to engage it in the fall because it gives the customer, especially on commercial contracts where sometimes there is a delay between you giving a quote, the customer forwarding it to their client, because you also might be a subcontractor. So you're working for a third party and then they have to get it approved through their actual client. So there might be a like 1 or 2 months delay of the quote or the work actually getting approved. Especially if it's preventative, because it's not like an immediate problem and they might need to find the funds, or they might like, there's so much going on that you don't know, that you as a technician, you go on site, you locate the unit, you find out what is going on with the unit, and then you write up and you document with pictures and measurements and technical data what is going on. So you can let the customer know and they can decide based on what you provide them, you know. You can only do recommendations because they're the ones paying you. So if they don't want to pay you, then they don't pay you. It's still your job to let them know.
Okay, that makes sense. Alrighty. Okay, well, I guess that ends our call for today.
Did you have any other questions, or that was
all? That was my only question.
That was your only question. Okay, good.
Okay.
Okay, well, I guess we only covered fall PMs, and maybe next time we can go over refrigeration a little bit more.
Okay, no problem.
Sounds good.
Okay, Bye.
Okay, have a good one. Bye.
Bye.